All right, welcome back to Geometries. We're in section 2.5 now, and in section 2.5 we're going to be having an introduction, I suppose, to one of my favorite things about geometry. All right, and one of my favorite things about geometry are what are called proofs. We're going to have to be able to write proofs for things that we know about geometric figures. Now, I like that because I like arguing and justifying my argument so that I know that I'm right. I just like to be right. It's kind of a fun thing. I know that many of you enjoy arguing as well. I've experienced that in class, but in a fun way. I'm not trying to say anything bad there, but you guys like to try to persuade, right? And if you're going to try to persuade, you got to make arguments with justifications for those arguments, don't you? And so that's what we're going to be developing. That's the kind of skill we're going to be developing here. But we're going to be developing that for the sake of making arguments about geometric shapes. All right, now we're going to start that using some algebra, actually. In this section, we're going to look at reason using properties from algebra, or how to reason using properties from algebra would be a better way of stating that. And in this video, we're going to approach lesson goal 1. This is supposed to be a 2 down there, of course. In lesson goal 1, we're going to use algebraic properties of equality to justify the steps that you use to solve an equation. All right? And then in lesson goal 2, which will be the next video, we'll use properties of equality involving segment lengths and angle measures, and we'll use those in order to justify statements about geometric figures. That'll make more sense in the next video when we get there. Let's talk about properties of equality. And in particular, how we use those properties of equality to justify steps for solving equations. All right, now whenever we're talking about a property of equality, here's one thing I need you to know. And that is that a property of equality is a property about equations. It's not a property about an expression, it's a property about an equation. Okay. And here is the first of those properties that we're going to discuss. Simply, it's the addition property. Now, because of the way I labeled this here, I didn't write of equality, but I want you to think about this being the addition property of equality. Okay, you'll see later on why I'm saying that. And here's what the addition property of equality says. If I have two values a and b that are equal to one another, and I increase the value of a by c, in order for the two sides of the equation to be equal, I must also increase the value b by c. All right? Now, I'll summarize that this way. If you add something to one side of an equation, you have to add the same thing to the other side of the equation in order for the two sides to be equal, don't you? That's something you're very familiar with. You've just never given a name to it, but it's the addition property of equality that says that that's going to be the case. The two sides will still be equal after you add c to both sides. All right, so for example, remember, we're trying to justify steps for solving equations. If you're going to solve this equation 3x minus 7 equals 17, well, you would want to cancel out this minus 7, wouldn't you? And you would do that by adding 7 to the minus 7. And if you add 7 to the left side of the equation, you got to add it to the right side of the equation. And the result then would be that 3x equals 24. Let me illustrate that. Okay, so in order to cancel out the minus 7 on the left side of the equation, we added a positive 7. All right, the 7's cancel in that case. But right now, the left side is 7 more than the right side. I've got to increase the right side of the equation by 7 as well. So you can see how we got 3x on the left and 24 on the right. All right, nothing mind-shattering, but it is something that we need to understand right now. All right, now you might guess that if there's an addition property of equality, there's also a subtraction property of equality. And it's essentially the same thing, but with subtraction. If you have an equation and you subtract c from one side of that equation, you would have to subtract c from the other side of the equation as well. Subtract the same thing from both sides if you subtract something from either side of the equation. All right, so if I was solving the equation 6 plus 9x equals 3x, and I was trying to get my x's on the same side of the equation, I would have to cancel out this 9x by subtracting 9x from both sides. And the result of subtracting 9x from both sides would be what you see on your screen right now. All right, and all I did to get there was subtract 9x from the left side of the equation, and because I subtracted it from one side, I subtracted it from the other as well. And you can see how these cancel. leaves you with 6, and 3x minus 9x is negative 6x. Great. Then there's a multiplication property of equality, naturally, as well as the division property. I'll illustrate each of those really quickly. And as you might guess, the multiplication property of equality would be that if you have an equation and you multiply one side of it by c, you multiply the other side by c. So if 2/5 x was equal to 16, then x would be 40. Now, what did I do to solve that equation? Remember, whenever you are solving an equation and you're trying to get rid of a fractional coefficient, well, you multiply both sides by the reciprocal of that coefficient. So, I'm multiplying the left side of the equation by 5/2. Alright, and then 2/5, the 2's cancel, times 5/2. 2's cancel, the 5's cancel, it just leaves you with x. I've got to multiply the right side of the equation by that same value. That's basically 16 times 5 divided by 2, which is 80 divided by 2, or 40. Okay, then the division property of equality. Alright, if a equals b, then a divided by c equals b divided by c. If you divide the left side by something, you've got to divide the right side of the equation by the same thing. And this, you won't need me to illustrate so much as just point things out. If negative 9x equals 36, well, to get x by itself, you'd have to divide by negative 9 on the left side, wouldn't you? So you have to divide by negative 9 on the right side as well. Alright, and if I divide both sides by negative 9, I'm going to get a positive 1x here. I'm going to get a negative 4 there. Excellent. So there are some properties of equality that we're going to be using. We're also going to be using the distributive property, which works for expressions as well as within equations, so it's not really a property of equality, but it is something that you're going to see within the problems that we're going to work here. And here's what we're going to be doing for problems. Oh, you know what? There's a whole other property that I forgot to mention right here. Alright, substitution property of equality. It's one you've used many times, but it's not quite the same thing as the other ones that we've just used. The substitution property of equality is this. If you have an equation, if you happen to know that a value a equals b, then you can substitute a in place of b in any equation or expression. Alright, you can substitute a in place of b for any equation or expression if the two values are equal. So, for instance, let's say that I know that x plus 2y equals 10, and I know that y is equal to x minus 1. Well, in that case, then this would be true. X plus 2 times x minus 1 is equal to 10. And why could I make that conclusion? Well, y was equal to x minus 1, right? So, where I had a y in this first equation, I was able to replace that or substitute x minus 1 in its place. Now there's still a lot more to be done to solve that equation, but you see how I substituted one value in place of another equal value within an equation. Alright, that's the substitution property of equality. Now for what I was trying to do a minute ago. Alright, what we're going to be doing, of course, is justifying steps for solving equations, and so we're going to be solving equations. And we're going to solve equations, and we're going to write a reason for each step. Now, the solving of these equations you've done before, but you've never written a reason for each step. And the way I've got this set up is, here's the original equation, this is what we're trying to solve, and in this equation column, we're going to keep writing down what are the things that we get as we add something to both sides of the equation, or subtract something from both sides of the equation, and so forth. And on the right, what we're going to do is we're going to write a reason for why we know that this equation is true, each step of the way. Okay, so we're going to write a reason for why we know the equation in the left-hand column is true for every equation that we write. Now, use what you know about solving equations here. You ought to recognize that the first thing that we're going to do with this equation is we're going to use the distributive property. Alright, so we're going to multiply 1/3 times x. Copy down the minus side. 1/3 times 12 is 4. then we still got minus 5 equals negative 10. Okay, now in the right-hand column, we're writing a reason for why the left-hand column must be true. And actually, we have already skipped a step here. The reason we knew that 1/3 times x minus 12 minus 5 equals negative 10 was true is because that was given to us for this problem. We were told that equality was true for this problem. But then why do we know that if that's true that 1/3 x minus 4 minus 5 equals negative 10? Well, we use the distributive property to make that conclusion. And according to the distributive property then, those two things have to be equal to one another. Make sense? All right, next step. We're going to have to combine our like terms on the left side of the equation. So that'll give us 1/3 x minus 9 equals negative 10. And whenever you combine like terms, what you've done is simplify. So because we simplified, we know that this equation, the third equation, is equivalent to the one above it. All right, now we're going to have to add 9 to both sides, and we'll get 1/3 x is equal to negative 1. And since we added positive 9 to both sides, since we added the same thing to both sides of the equation, we can say this new equation is true because of the addition property of equality. Now, when it's a property of equality, I want you to write this, addition property of equality. That's kind of a simplified way of writing out that property. All right, now we got one more step in solving this equation, and I'm going to have to make some more room on my screen. So if you haven't written all this down yet, write it down. Okay, and of course the last step in solving this equation is since we have 1/3 x, we got to multiply both sides by the reciprocal of 1/3. We got to multiply both sides by 3 in order to get x by itself. And 1/3 x times 3 is x. Negative 1 times 3 is negative 3. Since we multiplied both sides of the equation by the same value, that means we use the multiplication property of equality. Alright, so that is how we solve an equation and justify the reason we know each step of the equation is true. Let's try another. Now, if you think you understood all the steps in that last equation, I would like you to try this one on your own so you can pause the video and then come back and hear my explanation for it. And if you're not ready to do that yet, just go ahead and listen to my explanation for this one. And there's still one more example that we're going to try, and you can try that one on your own here in a little bit. Okay, now we have to give a reason why we know the equation we write on the left is true at every step of the way. And of course, the reason we know that negative 7 times 2x plus 1 equals 5 times negative 3x minus 2 is because for this problem, that was given to you. All right, you'll get used to using that given as a reason quite a lot. All right, now the first step in solving this equation is going to be using distributive property again, it turns out, right? So let's distribute the negative 7 on the left side of the equation. And while we're using the distributive property, let's go ahead and distribute the 5 on the right side of the equation. All right, so the reason we know this equation is true is because we use the distributive property. Which is not a property of equality because it works for expressions, so we're not going to write of equality there. All right, then we're going to try to get our constants on the one side of the equation and our variables on the other. Let's go ahead and try to cancel out the negative 15x here. Bring it over to this side. And we're going to have to add positive 15x to both sides to make that happen. When we add positive 15x to the left side of the equation, it's just going to give us a positive 1x. When we add positive 15x to the right side of the equation, it's going to cancel out the negative 15x and leave us with negative 10. All right, and we added the same value to both sides of the equation, so we use the addition. I'm going to start abbreviating a lot more here. Property. Trying to write a period, it won't let me. All right, of equality. All right, then the last step here is we're going to have to add 7 to both sides of the equation to get x by itself. That cancels out the negative 7 on the left, gives us negative 3 on the right. I didn't mean to make both those equations have the same answer, but they do. And that last step, we added 7 to both sides, so we again used the addition property of equality. All right, I would definitely like you to try this next one on your own and then listen to my explanation. So, whoa, well, there's not really a next one there. Hold on. All right, that's because I skipped over the first one I was going to do. Here's the one I want you to try on your own. Go for it. All right, so check your work with mine. I started off by saying that the original equation was given to us. Sorry, that was a... Oh yeah, well, this equation was true because it was given to us. And then what I had to do with this equation, of course, was combine my like terms to begin. So I combined the 25 and 17 and got this 42. And so I know that this equation is equivalent to the previous one because all I did was simplify the expressions that were within the equation. All right. Then I decided to cancel out the negative 3x by adding 3x to both sides, which gave me a 7x over here. And so since I added the same thing to both sides, that was using the addition property of equality. And since my variables are on the right side, I needed to cancel out the constants on the right side of the equation. And I had to cancel out that plus 14 by subtracting 14 from both sides, and that gave me 28 over here. Since I subtracted both sides by 14, the reason I know this equation and this equation are equal is because of the subtraction property of equality. Now notice when I abbreviated subtraction, I didn't just do SUB, I did SUBT, because there's also the substitution property of equality, and so I had to put enough letters so I know this is subtraction instead of substitution. All right, and then finally, of course, I had to divide both sides by 7 in order to get x by itself. And when you divide both sides of an equation by the same thing, you're using the division property of equality. All right, so that's how you use properties of equality to justify your steps for solving equations. I didn't get to illustrate the use of the substitution property within a problem. We'll get to do that within the next lesson. Hopefully this will all make sense, though. I will see you next time.